Ever since the Artemis II astronauts circled the moon and returned safely to Earth, the global expectation has been clear. The very next mission will finally put human boots back on the lunar surface. But that is no longer happening. NASA has quietly altered the timeline, and Artemis III will not be touching down on the moon. On paper, the space agency appears ready to go. They have the Space Launch System, the most powerful operational rocket in the world, sitting on the pad, fully capable of throwing heavy payloads into deep space. And they have the Orion capsule, a fully tested crew vehicle built to carry 4 astronauts safely through the vacuum of space. But Orion has a strict limitation. It is designed exclusively to orbit the moon, not land on it. To actually get down to the surface, the astronauts need a completely separate vehicle, a human landing system. And right now, NASA doesn't have one. So despite spending billions of dollars and building the infrastructure to traverse hundreds of thousands of miles, the agency is missing the final 60 miles. If they launched today, the crew would be stranded in orbit, looking down at a surface they have no way to reach. To bridge that gap, NASA made a highly unusual decision. Instead of building the lander in-house, they outsourced the entire project to the private sector, placing the future of the lunar program in the hands of commercial companies run by billionaires like Elon Musk. There is undeniable progress. SpaceX has built actual towering stainless steel prototypes of their Starship vehicle, proving that physical hardware is making its way to the launch pad. But developing a lunar lander from scratch requires aggressive testing, and Starship's flight record is littered with wreckage. Early prototypes repeatedly ended in blinding fireballs, and several orbital attempts have resulted in the vehicle breaking apart mid-air. The second contractor isn't faring much better. Blue Origin had made significant strides with their New Glenn rocket, but in May 2026, a catastrophic engine failure completely destroyed their only operational launch pad in a massive explosion. Tying the Artemis timeline to these private companies introduced an enormous amount of risk. Developing and testing these highly destructive experimental machines operates on a timeline that simply does not align with a rigid scheduled lunar return. And there is a much deeper physics problem. These new landers are so massive that simply escaping Earth's gravity burns through nearly their entire fuel supply. This diagram highlights the core issue. By the time the lander reaches orbit, its fuel gauge is virtually empty. Before it can even begin the journey to the moon, it has to be refueled in the vacuum of space. NASA estimates that fully fueling a single Starship lander will require up to 15 separate tanker flights. All of these tankers must rendezvous and transfer super-chilled propellants while traveling thousands of miles per hour. Rushing to solve engineering challenges of this magnitude has a dark history. In April 1967, Soviet cosmonaut Vladimir Komarov boarded the Soyuz 1 spacecraft, despite engineers documenting over 200 technical faults with the vehicle. Driven by immense political pressure to meet a deadline, the Soviet Union launched anyway. The systems failed almost immediately in orbit, and Komarov was killed when the capsule slammed into the Earth. Attempting orbital refueling for the first time, millions of miles away from Earth, carries that exact same risk. NASA knows that placing astronauts into a completely unproven system with known technical hurdles is a recipe for disaster. If a critical failure happens 3 days away in lunar orbit, there is no rescue mission. Facing this reality, the agency chose to prioritize the survival of their astronauts over meeting an arbitrary political deadline. This is why Artemis III has been completely repurposed. Instead of a lunar landing, it is now a high-stakes test mission, taking place entirely within Earth's orbit. The private landers will launch on their own rockets and wait in low Earth orbit. Only then will the Orion capsule launch, carrying the crew up to rendezvous with the hardware. Once there, the astronauts will manually dock with the landers. They will cross the threshold in their survival suits, powering up the cabins to verify the life support systems, communications, and structural integrity. Conducting these tests close to home provides a crucial safety net. If a system fails or a warning light flashes red, the crew can simply undock and return to Earth in a matter of hours. If these systems pass, the next step will be an uncrewed lunar landing, an Artemis 3.5, to prove the automation works. Only after that succeeds will humans finally step aboard the lander for Artemis IV. This chart illustrates the growing pressure on NASA's timeline. While the United States relies on a shifting schedule tied to private contractors, China is executing a rigid, state-backed space program that is on track to establish a lunar base by 2030. The modern space race is no longer just about sprinting to plant a flag and immediately coming home. It is about taking the time to build and verify a reliable, safe infrastructure, ensuring that when humanity finally returns to the moon, we can stay there for good.